Hello guys, my name is Krishna Sharma and today I am presenting my term project titled Fake News Detection using TF-IDF and Multinomial Naive Bayes, a machine learning approach. So, the main objective of this project is to automatically classify online news article as either real or fake using machine learning techniques. The project was implemented in Python using Jupyter Notebook and evaluated using standard classification metrics. Okay guys, so let's proceed. So yeah, problem statement. Nowadays, millions of news articles are published every day through websites and social media platforms, as you all know. Unfortunately, fake news spreads very quickly and often reaches thousands of people before it can be verified. Manual verification performed by journalists and fact checkers is accurate but is very time consuming and difficult to perform at such a large scale. Therefore, the goal of this project is to develop an automated machine learning model that can be classify a news article as either real or fake with high accuracy and minimal processing time. Okay, yeah, so here our slide 3 dataset. So for this project I usually use two publicly available dataset from Kaggle. The first dataset is True.csv, which contains genuine news articles. The second dataset is Fake.csv, which contains fake news articles. Now, after assigning labels where 0 represents real news article and 1 represents fake news article, both datasets were merged into a single dataset and shuffled randomly before training. So the final dataset contains approximately 44,898 news articles, which are, I think, a huge number, including 21,417 real news articles and 23,481 fake news articles. Okay, so methodology. So how our system will work. So the workflow of this project consists of several steps. First, both datasets are loaded into Python using the pandas library. The next, labels are assigned to distinguish between real and fake news. The datasets are merged and shuffled to remove any ordering bias. For each news article, I combine the title, article text and subject into one text field so that the model can learn from all available textual information. Now, since machine learning algorithms cannot understand raw text, I converted the text into numerical feature vector using TF-IDF, which stands for Term Frequency Inverse Document Frequency. Now TF-IDF assigns higher importance to words that appear frequently within one document but are uncommon across the entire dataset. This helps the model focus on informative words instead of common words such as the, is, or and. After feature extraction, the dataset is divided into 80% training data and 20% testing data using a stratified train test split to maintain the same class distribution in both sets. Okay, so model selection. So the classification algorithm used in this project is multinomial naive Bayes. I selected this algorithm because it is widely used for text classification problems such as spam detection, sentiment analysis, and fake news detection. It is computationally efficient, requires less training time, and performs very well when combined with TF-IDF feature vectors. During training, the algorithm learns the probability distribution of words associated with each class and uses these probabilities to classify new unseen articles as either real or fake. Now, the results. So, to evaluate the performance of the model, I use several evaluation metrics including accuracy, precision, recall, F1 score, confusion metrics, and k-fold cross validation. The model achieved an overall accuracy of 94%. I think this is fine. This is a perfect, I can say. For the real news class, precision is 0.9335, recall is 0.9475, F1 score is 0.9404, and for the fake news classes, precision is 0.9467, recall is 0.9325, F1 score is 0.9395. The confusion matrix also demonstrates strong performance. Out of the testing samples, 379 real news articles and 373 fake news articles were classified correctly, while only a small number of articles were misclassified. Additionally, I performed k-fold cross-validation to ensure that the model generalizes well and is not overfitting to a single trained test split. Okay, now discussion. So one of the biggest strengths of this project is its simplicity and computational efficiency. Compared to deep learning models, the combination of TF-IDF and multinomial naive Bayes requires significantly less computational power while still providing excellent classification accuracy. However, there are some limitations. The model only uses textual information and does not consider factors such as the credibility of the publisher, author information, publication history, or multimedia content. Also, the model currently supports only English language news article. Okay, now conclusion and future work. To conclude, this project successfully demonstrates that machine learning can effectively detect fake news using textual content. By combining TF-IDF feature extraction with the multinomial naive Bayes classifier, the model achieved an overall accuracy of 94%, making it both efficient and practical for fake news classification. In the future, this project can be extended by using advanced deep learning models such as LSTM, GRU, or BERT, supporting multiple language, incorporating metadata such as publisher information, and deploying the model as a real-time web application where users can paste a news article or URL for instant prediction. So this was my overall project. This was my model, which totally created by me only. Thank you for your time and attention. This concludes my presentation. Thanks, guys.